Hi there and welcome to Having Fun with Chemical Theory. This is Activity 3 for Year 8, looking at change in state. Now in Activity 2 we looked at the idea that there are three states of matter. There's solid, there's liquid and there's gas. And we basically came up with the idea that different particles will have certain amounts of energy, and as a result the amount of energy they have will determine what state they're going to be in. Now, what we also notice is that if we give particles of matter a certain amount of energy, they're going to do what we call change state. They're going to move from a solid to a liquid to a gas. And likewise, if we remove the energy that the particles have, they'll go in the opposite direction. Gas to a liquid, liquid to a solid. Now, there are certain points at which we're going to get these changes occurring. Now the first point that we have is when a solid turns into a liquid. Now we call that the melting point. And at this point what we have is the particles having enough energy where their bonds are not completely broken, they're almost like in an elastic state, so the particles have the ability to slide over each other. Every element will actually have, or every material will actually have a melting point, a temperature at which they have gained enough energy where they can change from a solid into a liquid state. The next change of state is when we go from a liquid to a gas. Now we all know that when we turn a liquid into a gas, we boil it. Again, in this case, the particles now have enough energy where they can actually break the bonds holding the particles together. And this produces, again, a specific temperature per material, which will be called the boiling point. Obviously, if we're going in the opposite direction, we can have a gas going to a liquid, and in this case we get condensation. Now this is the sort of thing that you'll see if you go and breathe on a window. If you breathe on a window, what happens is the water vapor inside your breath condenses on the window, turning into a liquid. Now the glass window is actually colder than your breath, and as a result absorbs all the energy. Because it absorbs all the energy, the particles have got less energy, and as a result they change from going from a gaseous state into a liquid state. So that's condensation. As we go from a liquid to a solid, we know that we call that freezing. And again, there's a point at which the liquid will actually freeze. For example, water will freeze at 0 degrees. In this case, again, the energy has been removed from the particles to the point that they have virtually no energy at all except for vibrational energy. Now there is one other process that that can happen for states of matter, and that's where a solid can change straight into a gas. And an example of that is dry ice. You add dry ice to water, it starts as a solid and it goes straight into a gas. It's the sort of thing they used to use to make fog in the theatre. Now, this process is called sublimation. And what this means is that the energy is so great that the material of the solid bypasses the liquid stage and goes straight into a gas stage. So, the 5 things that you need to know. Melting is where you gain enough energy to change from solid to liquid. Boiling, when you gain enough energy to change the liquid into a gas. Condensing, where you lose energy and you change from a gas to a liquid. And freezing, where you again lose more energy and you change from a liquid state to a solid. And finally we've got sublimation, where a solid can go straight into a gas, bypassing the liquid stage. Now in class what we've done is we did a practical where we heated water, and we came up with a specific heating curve for water. And this allows us to demonstrate what is happening in the with respect to the particles with the concept of time and temperature. So if we remember, when we started off with some ice in a beaker, and we started heating it with a Bunsen burner. And what we noticed was we got a curve that looks similar to the one shown in red. At the bottom you can see that you've got a diagonal line which goes below 0, at which point the ice is in a solid state. Then we have a period of time where the temperature remains constant. Now at this point what's happening is the ice is beginning to melt, but all the particles have not gained all the energy necessary to change it into a liquid state. So as a result, all the energy that's been given to the ice by the Bunsen burner is basically going into the particles. The particles are slowly moving apart, and this takes time. As a result, the temperature remains at a constant level. Once all the particles have got enough energy, then what happens is the temperature can rise dramatically, and as energy is added, we see a dramatic increase in the temperature, and we go into a liquid state. Note that at the point where it changes into a diagonal, that is going to be the boiling point for our substance. So the temperature keeps increasing and increasing and increasing. The particles get more and more energy in that liquid state until we reach a point where it begins to boil. Now for water, water boils at 100 degrees C. And at this point, the liquid particles have now got enough energy to break free of their partners and go off in a random state in the form of a gas. Now the temperature never gets any higher than this temperature, because what's happening is the water particles are coming off as steam and taking the energy away, which means that the energy never increases inside the water. It remains constant. Now if we go in the other way, we can look at what we call the cooling curve. Now if we took steam as our starting point and we cooled it down, we would condense it. This would cause the temperature to begin to decrease. The gas particles would now clump together and become a liquid, and that is because they'd be losing energy. The energy has been removed. Now if we keep condensing, we'll then get to a point where basically the liquid particles have not got enough energy to move around, and we will call that the freezing point. And at that point we would notice that it had turned into a solid. So basically we've got the idea that when we're going from solid to gas, we're gaining energy, going through the processes of melting and boiling, noticing that when we have melting, the energy remains fairly constant until all the particles have got the right amount of energy, and then off they go. They can actually increase in temperature. Likewise, when we come in the opposite direction, we condense it down, we remove the energy, and the result is we can then go through the gas, liquid and solid state. Okay, well I hope that makes sense. If you have a look on the iTunes U course, you'll see in this section of the course activity 3, and that will give you a question which you can answer looking at this graph and hopefully consolidating what you've learned in this video. Thanks for watching, and hopefully I'll see you again in activity 4.